Okay, so it's 5 p.m. and let us start. So what I wanted to do is today we are going to discuss week 5, and if there is time we will also discuss week 6, some of the questions. Okay, so I will take questions in a bunch of 5, and once I have taken those 5 questions I will be discussing those 5 questions in the next 15 or 20 minutes, maybe 30 minutes. And once I am done with those 5 questions I will take another 5 questions. Okay. Yeah.
Hello, sir.
Yeah, hello.
Sir, I have a dot in 5.4, I guess. Yeah, 5.4
Okay.
marginal density.
Thank you. 5.4. Any question or whole lecture?
Yeah, yes, sir. In 5.4, I have a dot in. Sir, how to find the marginal density of f of y means how sir is doing the slicing when he is taking the f of y.
Okay. So to compute.
Can you visualize it in on the distmos or something?
Okay. 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 So regarding this, we will have an GeoGebra applet. So
Yeah,
that
yeah.
I am going to
On
take it
GeoGebra, you
on.
can.
I
Mhm.
am going to take on Tuesday. So in that I will show you exactly how those slicings are happening using GeoGebra applets. Okay. Now I don't have those applets now. So maybe I will get it in a couple of days, and on Tuesday I will discuss these densities and areas and how to find this uh,
Meanwhile, sir,
probability density functions.
uh, you can you can yeah,
Yeah. Okay. So on board.
5.4 question number 2. Yes, sir.
Hmm.
You can
Okay.
solve yeah,
Yeah, yeah. I will solve
5.4
that
question.
5.4 question number 2.
Mm-hmm.
Mhm. And second.
And in the lecture 5.4,
Hmm.
uh, sir is doing slicing at a timestamp. I think it is on. Yeah, it is on 16 minute. So can you yeah
Okay.
can you elaborate on that?
Yeah, yeah. Sure.
How sir is doing that slicing and
Sure, sure.
all this? Yeah, okay.
Yeah, yeah. No doubt, sir. Rest of the people.
Sir, in activity 5.3,
Hmm.
I have doubt in question number 3
Hmm.
and question number 11.
Hmm.
That's it.
Okay.
And sir, in activity 5.2, I have question number 3. I have doubt in that. I've solved it, but my answer is not matching.
Okay. Last one.
And sir, in activity 5.4,
Just
question number.
Srishti. Wait. Let's give someone chance. I will
Okay,
take
okay,
your next question in the next set of 5. Okay.
okay, sir.
Okay. Yeah. SKP.
Sir, I have difficulty in calculating marginals.
Yeah. That will come here. We will look at that lecture 5.4.
Okay, yeah, in this lecture, yeah, and this one.
Okay. Okay.
Okay, okay,
Okay.
sir.
Then let us do this first. Okay. I will start with 5.2 lecture. I will
Okay,
do
sir.
this,
Fine, sir.
and we will see lecture 5.4, and we will solve that 5.4
Thank,
question number 2.
thank you, sir.
Okay. Yeah. Sure. Sure. Then let us start this. AQ 5.2 question number 3. So let me look at the question. So it's like random variable x, which is Bernoulli 0.5. Is that the question?
Yes, sir.
Hmm. So do you have problem in whole question or at some
No,
point
sir, only the solution part.
solution part? What are you getting?
Sir, I have calculated probability of x equals to 0 given y equals to -1, and I have used this formula probability x0 into conditional probability of y given x0 minus
Hmm.
1 upon f of y minus 1.
Hmm.
And then, so using this, I'm getting 2 e to the power 2,
Hmm.
2 into e to the power 2 upon 2 into e to the power 2 plus 1 upon under root 2 pi e to the power minus 1 by 2.
For -1, is it?
Yes, sir, for minus 1. X equals to 0 given y equals to minus 1.
Okay. Okay, let me do this. So it has been given that
Excuse me,
x
sir.
is, yeah,
Sir, I have doubt in activity question 5.6.
yeah, Vaibhav, okay, just wait for some 15 to 20 minutes. I have set off for some 5 questions with me. Let me solve those
Sure, sir.
first 5, and I will take next 5. Okay.
Sure, sir. Thank you,
Yeah,
sir.
sure. So can someone post this in Zoom chat box, please? Uh, Stating that uh, I'm going to take 5 questions, bunch of 5 questions every day. Okay, those who have joined late also they can see. Okay, x is given as
Okay.
Bernoulli 0.5. Also, we have a random variable y, which is a continuous random variable. Sorry, y given x is equals to 0 is a continuous random variable which follows exponential distribution with mean 2, right? And again, there is y given x is equals to 1, which is normal 0, 1. Okay, now tell me, uh, so okay, we have to find this thing. So this is nothing but,
अरे वहाँ तमिल के थोड़ी होता है
hmm,
नहीं नहीं
Vaibhav, can you mute please? Okay, so this can be written as like this, right? So this is given y equals to -1. So I can write it as probability that x is equals to 0 and probability that and y is equals to -1 divided by probability that y takes -1. Right? This is the joint probability. This I can write it as marginal into conditional.
Sir, I have used a different formula here. Yeah,
Which one?
this one, this what you are writing just now.
Mm-hmm.
That's the same thing. No?
You are using this thing only, right?
And, upon this probability of y equals to minus 1.
Yeah, probability. So this is nothing but fy -1.
Yeah.
This thing only, right?
Yes, sir.
Okay. Tell me this. What is the probability that y takes -1 given x is equals to 0?
So 2 into e to the power 2.
Uh, okay. First, tell me what is exponential function PDF?
So it's lambda
So
into
1 minus.
So if it is,
1.
uh, what is this?
So 1 minus lambda into e to the power minus lambda.
I'm asking about PDF.
Okay.
PDF is
Lambda into
lambda
e to the power minus lambda.
Minus lambda.
Lambda e to the power minus lambda
Minus
x.
lambda x.
When x is
Greater than 0.
Greater than 0.
greater than 0, right? Now observe here, this particular distribution y given x is equals to 0 is an exponential 2. Okay, this y given x is equals to 0 is an exponential function.
Yes.
If it is an exponential function, what is the probability that that particular exponential function takes value -1? So what is the probability that
0, right?
fx taking -1?
0.
Yeah, it would be 0.
0, right?
Yeah.
So here x is nothing but y given x is equals to 0,
Okay.
right? So this is an exponential function, and exponential functions cannot take negative values. So if I am giving a negative value, the probability that x taking -1 is 0. or y taking -1 given x is equals to 0 is 0. So this particular thing goes to 0. Sorry, not goes to 0, is equal to 0. Got it?
Okay, sir. So,
So
what is the
let us just
probability for x equals to 1 and y equals to -1, given y equals to -1?
probability that
X equals to 1, given y equals to -1.
x is equals to 1 given y is equals to -1.
Yeah.
Follow the same trend. No? Probability that x is equals to 1. So this is 0. And again
Again,
this
it
thing.
will be 0. No, sir.
Again, see, the thing is, now see,
No, sir. It is.
this will become fx. This is not 0. This will
This
be
is not
fx of
0.
fx of 1 times f y
Y
given x is equals to 1
1 and it is
minus
defined.
1 divided by fy of -1. Now you see, you compute this thing fx of -1, fx of 1. So x is a Bernoulli 0.5. What is the probability that x takes value 1?
0.5.
Yes, sir.
0.5.
So
0.5.
fx1 is equals to fx0 is equals to 0.5.
Mm.
This will imply this. Now this is 0.5 times. Now what is this distribution? Y given x is equals to 1.
Normal.
It's a
That's
normal
normal.
0.
Yeah.
So what is the PDF of it?
So it
1
will
by
be 1
root
upon
1
uh,
by
uh,
2 pi
under root 2
sigma.
pi into sigma
e
e
power
to the power
minus
minus
x
y
square.
x minus mu whole
Okay, mu
square
is
upon
0
2.
and I'm just asking standard normal distribution. Okay,
Okay.
this is a standard normal, right?
X minus 0 whole square upon 2.
Upon 2. So that will give me, if I simplify that, it will be x square
Minus
by
x
2
square by 2.
Yes, sir,
minus x
minus
square by 2, and x is now we have -1. So we wanted to find the probability that it takes -1. So just substitute -1 in place of x.
It will be 1 by 2 then.
Yeah, it
Minus 1
will be
by 2.
-1 by 2
Yeah, minus 1 by 2.
divided by what is fy of -1?
So 0.5 into the same
0.5
thing, which is the
into this
numerator
thing.
part,
Yeah,
plus
yeah,
0.5 into
1 by root 2 pi
yeah,
into e power minus half, which is probability that uh, y is taking
minus 1 given x is
Minus.
1.
yeah, given x is equals to 1. Same
Yeah.
way, probability that y is -1 given x is equals to 0. What is that?
Y is minus 1 given x equals to 0.
Hmm.
So it will be 0.
0.5 e to the power 2.
So why it wouldn't be 0 then?
See this. So what is the marginal of what is marginal fy of y?
So it will
So
be
fy fy of y.
so limit of x.
Why you are going to limit of x and everything? It's just the summation, right?
Total probability, sir.
Yeah, summing.
Yeah, okay.
So shouldn't it be 2? Like e to the power 2 or minus 2?
Yeah. So this will be same like Bayes theorem if you understand it correctly. So you can correlate with this with that.
Yes, sir.
Fy of y, if I wanted to find the marginal distribution of this uh, continuous random variable, so it's just I can just write this fy of y as product of marginal into conditional. So summing over whole x, give me the marginal distribution of y. This was explained in lecture also, if you
Yes, sir. Yes, sir. I
remember.
remember. Yes,
Yeah,
sir.
yeah. So if y given x is equals to x is a if you know y given x is equals to x, and you know y is a continuous random variable and x is discrete, so marginal density of y can be written as fy of y. So you sum over all x's. So this is what we do in the discrete case also. If you want marginal of one random variable x, you will sum over all the unwanted random variable thing, right?
Okay, so one thing I have confusion in.
Hmm.
So in the previous case, which you have just solved here, we
Hmm.
are getting f of x minus 1 equals to 0.
F of
Because sir,
x.
you are saying that exponential is always x is greater than 0,
Right, right.
and yeah, so for it can't take negative values as well as 0.
Hmm.
So sir, here in this case, we are taking as f of y given x equals, sorry, f of y 0 given x
Hmm.
equals to 1.
Given
So
f of y is
sir, in
0.
denominator f of y minus 1,
Hmm.
we are taking the numerator thing, which is f of y given x equals to 1, f of y minus 1 given x equals to 1, then we are adding f of y um, 0 given x equals to 1.
No, no,
Sorry,
no.
sorry,
We are
f of y
adding.
minus 1 given x equals to 0. Yeah.
No, no. We are adding. Given x is equals to 0,
Hmm.
by taking value. Just hold on. Okay. Given x is equals to 0, y taking value minus 1 or 1.
Right. Yeah.
Okay,
Sir,
okay, okay, okay,
sir,
okay. So this is not. This will not be this. Okay, sorry.
So it should be 0 then. No?
Yeah, yeah, yeah.
Okay. So that was the confusion, because initially
Right.
you are taking it 0 and now you are writing the
Right,
value.
right, right, right. See, because if this is 0, no need to calculate all these things. See, now I got. See, probability that x will take either 0 or 1, right?
Yes, sir.
When y is equals to minus 1, x is taking 0 is 0.
Hmm.
Then what is the probability that x takes 1 given y is equals to minus 1? See, there are only two chances for x, either 0 or 1. Taking this particular value is 0 probability. What will be the probability of taking this
1.
value?
It will
one.
be
1.
1
1,
minus
yeah.
0.
Huh.
It would be the complement.
Yeah, 1 minus 0. 1 minus of
Yeah.
probability of this. So this will
Hmm.
be directly 1. Even if you follow this, you will get this and this will get cancelled and you will get 1.
So here you have written the which you have calculated just now, x
Mm,
equals to 0 given y equals to minus 1
mm,
equals to 0, because it can't take negative values.
yeah.
So this x equals to 0 given y equals to minus 1,
Mm,
we are getting f of we are getting 0 because of this f of y given f of y minus 1 given x equals to 0
yeah.
is 0. So we are
Uh,
getting the answer as 0. But sir, here y is taking minus 1 while
Mm.
x is 0. So why? Because y is minus 1, na whole thing is not negative. Why are we calling this thing here?
No, no. Y taking minus 1. See, this
Hmm.
particular thing is same as this thing, right?
Yeah. Yes, sir.
Once you are convinced with this, now look at this particular thing. Now we have two random variables which is x, and other random variable is y given x is equals to 0 is another random variable. You
Yes, sir.
forget about what is now we are not worried about what y is.
Hmm.
Okay. So we are now worried about only the random variable x and another random variable which is y given x is equals to 0. So depending upon those distributions, we calculate the probabilities.
Okay, sir. Because
Okay.
y given x equals to 0 is exponential function, so it
Yeah,
can't
y
take
given
value
x is
minus 1.
yeah, y given x is equals to 0 is an exponential function. So
Mm-hmm.
it cannot take negative value. So this will become 0. You
Okay,
don't know
okay, sir.
what
Now
to
I
do
got
between
this.
x and y to compute this,
Okay, sir. Thank you.
right? Yeah. So that is why this will be 0. Yeah, I have wasted bunch of time. No need to calculate all these things. As x is taking only two values, if that x taking one particular value is 0, then definitely x taking the other value will be 1 minus of 0, 1 minus 0, which is 1. Okay. So other thing is okay, right? Probability that x is taking 0 given y is equals to 1, and probability that x is taking 1 given y is equals to 1.
Yes, sir.
In this
Now I
particular,
can calculate this.
yeah, just compute this.
Okay.
Okay, so let us move to AQ3 then. Any doubts in AQ 5.2? Any other doubts? Anyone?
Yes, sir. So I joined bit late. So 5.2 question number 3. So given option D is also right. So
Hmm.
I'm not getting that.
Okay, so the same thing, right? This one only.
Okay.
Probability
Okay.
that X is taking 1 given
Okay.
Y.
Okay. Sorry. Okay. I got it. I got it. Now.
You got it. Huh?
I joined very late.
Okay. Okay, fine. So AQ
Excuse
5.3.
me, sir.
Hello.
Yes, sir.
Yeah, Vaibhav.
Sir, since you are taking activity questions 5.3, would you mind telling question number 6?
Okay, I will take that thing also. So 5.3, what is the other question which I got? Question number 3, is it? Okay, so we solve this. Now we are going to look at activity questions 5.3. Question number 3 and 11.
So one more question, question number 9 also.
3, 11, you are making to solve everything. Huh? 3, 9, 11, and what is that other one? Sixth one.
Yes, sir.
Right, okay. Okay, let me take the first question. So question number 3 is probability that y is greater than x. So we have been given you the joint density. They are asking us to find probability that y is greater than x. That is the question, right?
Yes, sir.
Am I right? Yeah.
So I have used graph method for
Yeah, graph
solving.
method. Okay. Okay, even I will take the graph method only. See, for these type of questions, using graph is better. Okay. Now I have the joint density as fxy, which is given as, so this is question number 3. 1 by 3 for 1 less than or equals to x less than or equals to 2, and other one is 0 to 3. Otherwise 0. Okay, let me draw this in graphical. So let us say this is 1, this is 2, and this is 3. So our distribution region will be this thing, right?
Yes,
Yes,
sir.
sir.
And the area is also 3. You see this width is 3 and this length is 1. So area will be 3 and the distribution is 1 by 3. So this is uniformly distributed in this region 1 to 2 and 0 to 3.
This area is 3, sir, because 1 by 3 is there. D is 3.
1?
1 by 3. This gives the area 3.
No. See,
Or just multiplying by the height and width.
multiply height and width, you will get area as 3. Then look at the joint density. If it is 1 by area, then you can confirm that this is uniformly distributed.
Okay. It means if we have plotted it and we got the area equal to the inverse of this, then we can say that it is
Yeah, that is uniformly distributed.
nicely plotted.
Yeah, nicely plotted and uniformly distributed in
Okay.
that
Fine.
range. Okay. Now what we have to
Hello.
find is, our
So
question
I
is
have calculated it now and now I got the answer.
answer. Okay. What's
Yes,
the
sir.
answer?
So answer is 0.5.
Very good. Correct. So it's just, so in order to compute these things, y greater than x, so just draw the line, how that line looks like.
So actually I have not divided it by the area of D.
Okay. So that is,
Yes.
so you might have got,
Yes, sir. Yes, sir. I have got the answer now.
Hello, sir.
Yeah.
Sir, actually, I have a doubt. Why we are taking inverse of the area as a joint joint PMF?
See, that is how we define the distribution. So if we say that it is
Is
uniformly
there any proof for that?
as of now, no worry. Don't worry about the proof. See, the proof is as simple. Taking this particular value, if it is x, so we treat it like there are these many points and these many points. Okay, the whole region will cover. Each of if it is if you if you sum all these points, you will get the area. That is what our general proof. Intuitively, if you look at
Yeah, this is sample space, sir.
Then
We
why we
can
are
say.
taking
okay, you see uniform. If I say if in discrete, if I say uniform 1, 2, 3, 4. So what you are doing for computing this
1/4, 1/4?
probability mass function? 1 by
4
number of
minus 1.
points, right? Number of points.
Okay,
1 by 4, right?
okay, yeah.
Okay.
Hmm.
So for like this intuitively, this is not the whole proof. Okay, there might be a complicated proof, but intuitively you can see that it's just like we are just dividing it with number of points. Okay. When it comes
Hmm.
to region, what we say is on number line, a point is equivalent to in an xy plane a region. So these all are pretty complicated stuff. No need to worry about that. As of now, remember that if you have a distribution like this, 1 by d in some region where d is the area and 0 otherwise, that means it is uniformly distributed in that region.
Okay, sir.
Okay.
As a curiosity, I just asked
Okay,
that
okay,
why
fine,
it is
fine.
taking inverse of that area for the joint PMF or
Fine, but yeah, if we talk about that, I guess most of the people will leave this meeting. Okay, better not to go in that deep. Okay,
Okay, okay, sir.
okay. So do I have to compute this or let me skip to other question? You got
You
that
can
right?
skip to the other question. Yes, sir,
Yeah.
I got
Okay,
it.
this you will get 0.5.
So in
Just draw the
question number
line.
9 also, I don't have doubt in the whole question, but I am not able to compute what will be the limit of y.
Okay, how to take the limits? Is it?
Yes, sir. The limit of the y is given as minus x to x. It's between
Hmm.
minus x to x. Then how will put the limits of y while integrating, while using the double integration thing?
Okay, just take it like strips. Okay, you take this strip, this
So in
particular.
question number 9.
Okay, in question number 9.
Yes, sir. Yes, sir.
Okay,
Can you please define this limit? Maybe.
yeah,
Yes,
yeah,
sir. Yes. Please,
yeah, yeah. I will.
please define the limit.
Okay, let me go. Is there any question which involves limit? Ninth question, I guess, right?
Yes, sir. Yes.
Okay.
Question 6 also.
Yeah, yeah, I will take this question 6 now. I will go to the ninth question next.
But
And
here,
finally,
sir,
we'll
in question number 3, how to define this limit?
Yeah,
Here,
that would be great, sir. If you tell me that.
that is the main point, sir.
in question number 3, is it?
Here only.
Yeah. Yes.
No need of limits here.
Okay.
It's just
Like.
an, you can play with area. You can
Integration.
just play with area. So
Okay.
at this point, 1 comma 1. This point,
Okay.
2 comma 2. So you just find
Sir,
the,
here we'll use the area of trapezium
yeah,
formula, right?
use the area of this trapezium and find the area of this trapezium. So the whole region is probability 1. So what will be the probability that of this region? Okay.
So we can also
Upper
compute.
region, right?
Yeah,
Y
yeah,
greater
sir.
than X will
Upper
be the
region
upper.
also.
Okay, y greater than x. Okay, then this will be the region. So this region, okay, this particular region is y greater than x, and this particular region is y less than x. So this is actually y is equals to x. You can see, you can just see. You randomly take 1 point above this line y is equals to x. So this will be something like 0.5 comma some 2.5. You can easily see that y will be greater than x, and take one random point in below. So while you look at the regions also look it like that. Take a random point somewhere, look the relation between x and y. So if it is
So
x
one
is
thing
greater than.
excuse
Hmm.
me, sir.
Mhm.
So in region part, I was taking one concept here. If
Hmm.
y is greater than x, then means it means that we have to shade the region towards the sorry away from the origin or away from the axis. And if y is less than x, then I should shade the region towards the axis or towards the origin. So is this concept good for every question?
You are saying that away. Okay, why if y is greater than. Okay, in in first quadrant it is true. Okay, as of now we are only no we have questions in all the four quadrants also, right?
Sir,
See,
it is the area between bounded by the x-axis and the line.
x-axis and
The line. Then what C is telling is it will be valid for all the
I
regions.
think it is true for only y equal to x.
see,
X-axis and the
whatever you
line.
are saying, y greater than x is this region, right? But in this particular third quadrant, I am actually plotting towards the origin, right?
Yeah.
But the bounded area is between the negative x and this line, sir.
Yeah.
Then y greater than x will be away from the x-axis.
Mm-hmm. So,
But sir, till now in we are taking question only in the first quadrants, I think.
okay.
Yeah.
But what about this seventh question?
It may happen like.
Okay. In first
Let
quadrant,
us.
whatever you said is true. Okay. So,
So
but
in
in
seventh
general
question, I have
case,
also used this first quadrant thing also. Yeah.
okay. So,
And sir, I have got the right answer.
fine. Then
So
you are
accidentally in all the question I'm using the same consent and everywhere I was getting the same thing.
But
The
see,
right
raised a
answer.
good question, sir. If it is absolutely valid for all, we can it will be easier. Well, time will be taken to find
Because sir,
plot.
plotting the points and putting the values and checking the things like that will consume a lot of time and
Yeah,
efforts.
what she is telling you that.
okay. Is it? I feel that won't take. See, that will give you an accurate answer.
Yeah.
Okay, you can trust on that.
Yeah.
But the thing is, when you are coming up with your own ideas or own concepts, it might have some exceptions somewhere. Until and unless you get an exception, you will see that it is you will look it as it is true, right?
So actually, this concepts I have got from the thing linear programming
Hmm.
from maths part, which is not in this course, but I have studied in class 12. So I have taken this thing from that this
Okay.
concept. So I have used here, and every time I'm getting the right answer using this part. So I think I need to discuss it from you that whether
Okay.
I'm right or not.
Okay. So let me take another line. Just tell me. This is x plus y is equals to some 2. Okay.
Yes, sir.
Uh, this is x plus y is equals to 2. Now tell me which region is x plus y less than 2.
So x plus y less than 2 is towards the origin.
Yeah, towards this thing. And greater than will be that side.
Away from it.
Mhm. So the same concept you used.
Yeah, it works, sir. It works. Most of the time it works.
Sir, what is being discussed? Actually, I'm not understanding.
Okay. She was discussing that how to find the regions of when a region is being asked like this, y is greater than x. This is a region, right?
Yeah, of course.
So how to find this region easily without even doing many calculations? How to
I
find
think
Whatever
that?
is closer
x
to
minus
the
y will be very
origin,
short.
that will be the lower bound, right?
No, no, just substitute the value of origin in that. If it's satisfied, it's towards the origin. Otherwise, it's away from the origin. That's all.
Yes, sir.
Yes,
Same
sir.
concept I also
Yeah.
use. Yeah, same
Right.
concept.
Sir, I think for x minus y equal to 2, it will be false.
X minus y is equals to 2. So what is x minus y is equals to 2? It is minus 2, this and this. Yeah, actually you can do this also. This is one good concept. Just substitute origin. If it is satisfying, then whole look at that region will belong to that thing.
Yeah, yeah.
So if you want x minus y less than 2, just substitute origin 0 0 0 0 less than 2 is satisfying. So this region will contain origin. So just shade towards the origin.
Yeah, yeah. This is a
Yeah,
good
so
idea.
same concept.
This is a good idea.
Yeah. So if origin is not satisfying this relation, that means origin will not come in that region. Shade the opposite region of the origin. That's it. So I don't think yeah, there are lots of concepts to shade these regions.
But this
And
will not work when it passes through the line passes through your origin.
line passes through origin, whatever
Then
set
another
you can
concept,
use.
what is bounded by the x-axis, and that will work.
Mm-hmm.
I
Yeah,
think so.
yeah. See, there will not be any complicated questions on how
Okay,
to
okay, sir.
find the
Fine.
how to find the regions. So there will be
Whether this
questions
only
like
uniform distribution will be there for the regions, or other distribution will also require.
as of now, uniform is
Yeah,
for
because
uniform you are using areas.
we have only using ideas for the uniform.
Mm-hmm.
Whether question will come for the other distributions also like this,
Uh, how can
then
I
how to calculate the
find?
area or exponential or other normal like that.
No.
Okay, question will be not like that.
Okay.
Okay, sir.
Okay. Let's come to this question. So, okay, this you will get 0.5. Just compute that area and divide the areas.
Okay, fine.
Okay. Now let's come to the sixth question. So sixth
Excuse me, sir.
question.
Sir, for question 6, I have calculated the joint density and it is correct. Sir, what I want that, sir, I want you to solve this question by using integration and not by area. Because I have solved 90% of my questions using integration only,
Okay.
and I'm not able to solve this one. So I wanted to solve this one by integration, if it's
Question
possible.
number 6
Yes, sir.
specifically, right? Okay. 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 D is uniform in between. D is a region. Let's plot this region first. It is given as 3x is greater than y, where 0 less than x less than 1 and y is greater than 0. Okay. For plotting this, I will just plot y is equals to 3x line. So this will be something like this. After plotting that, when will my 3x is greater than y? Okay, this will be the region, right? Once you look at that, and x is between 0 and 1. So this will be the region, and this is 3. Right? This is the region.
Yes, sir.
So now what I want is probability that y is greater than x is greater than 2y. So what for this thing, what I wanted to do is, this is basically probability that y is less than x, and at the same time that particular x is less than 2y, right?
Sir,
Identify the
sir,
hello.
can we integrate y from 0 to infinity and x from y to 2y? Will this will be the limits of integration?
Why we are doing 0 to infinite?
So because y is greater than 0. Okay, so y will be 0 to 3, right?
Yeah, y will be 0 to 3 only.
Okay.
Okay. So y is equals to x will be this line.
How did we calculate, sir? Why will be 0 to 3 only? 3x minus y.
Look at the distribution, right? Where is our region lying? It's between 0 to 3 only. It will not go beyond 3 because as x is in between 0 to 1 and we are looking at the region 3x greater than y. So
When
0
x is equal to 0, then y is greater than 0.
when x is equals to 0, why we are taking x is equals to 0 here?
How to get this 3
How to
mathematically?
get this 3? So
Yeah.
x will go till 1, right?
Okay.
So that means y can go till
Okay.
3 times 1.
Yeah.
Okay.
Yeah, I got it.
Yeah. So this is y is equals to x, and there will be another line y is equals to x by 2, which will be y is equals to x by 2. That will be like this, something like this.
So these two lines, first line is for probability
First line
x.
is for y equals to x. Second line is for x equals to 2y. Okay. We want the region in between these two lines. Am I correct, Vaibhav?
Yes, sir.
Now, how to find? So you wanted to use limits to calculate this area, right?
Yes, sir.
So for calculating area, what I will do is I will take a strip, some small strip at some x. Okay.
It is 2y. Why
Yes.
is this? We got 2y or it is 3y? 2y. We are fixing y is equal to x.
We are fixing
Y is equal to x.
No, we are trying to find the probability that x lies between y and 2y.
Yeah.
Okay. So in this region, x will lie in between y and 2y. So in this region. Okay. Y less than x is this region.
But this is the question, right?
Yeah, this is the question.
Yeah, got it.
Okay. So this is how we compute the limits. Just look at carefully. So I will take one small strip at any point x. Okay. And that strip, how my y is varying. My y is starting from x by 2 and going till x. Right. See,
Yes, sir.
in this particular strip, if this is y is equals to x and this is y is equals to x by 2, if this is x, then this will be x by 2 and this will be x. So this is x comma x and this is x comma x by 2. That means my y is starting from x by 2 and going till x. So my y will start from x by 2 and go till x. So this is y, and I will integrate on the whole x. So this is one small strip around x. Likewise, my x will take from 0 to 1. This is vertical strip. So if I am using vertical strip, that means I am integrating over whole x, whole region x. Inside that, I will integrate y in terms of x. So what I am doing is I am fixing one x first, one particular x first, and after fixing that x, I am looking at the limits of y. So my y limits will go from x by 2 to x at x, and I will integrate whole x. Okay. Or
Yes, sir.
if you don't want it to see in x's, I will take x is equals to 1. So when I take x is equals to 1, this particular thing is y is equals to half and this is y is equals to 1. So when x is equals to 1 strip line, around this strip x is equals to 1, or around this strip, along this strip, my y is running from 1 by 2 to, if okay, x is equals to 1, yeah, x is equals to 1 is this. So if you see here, my y is starting from half. This is y is equals to half to y is equals to, sorry, y is equals to half to y is equals to 1. So when x is taking value 1, y is running from 1 half to 1. Similarly, when I take x is equals to half, my y will run from 1 by 4. Y will go from 1 by 4 to 1 by 2. See, if I move x, my my y limits also moves. So in an x strip, if I take as an x, in this x, if I take this as an x, so my y moves from x by 2 to x. This is x by 2 and this is x. So this x can take values from 0 to 1. So one particular value of x, my y moves from x by 2 to x. So that is what I have written here. For one particular value of x, my y limits moves from x by 2 to x, and this particular x takes values from 0 to 1. So I have to take all the values of x and integrate 0 to 1 x by 2 to x. This will be fx y x comma y dy. So this is integral over d, and outside this is integral over x.
So can you take this limit x by 2 to x from the given interval x greater than y and less than 2y by putting the minimum and maximum, put the value of x.
Yeah.
Fixing the value x, we get one part y is equal to y is greater than 1 by 2, and on the left part x is greater than y.
Yeah.
So x is greater than y. So the value varies from x by 2 to x. Can we take everywhere like this? There are two part of this that is there. X is less than 2y, x is greater than y. What you have mentioned. We can take directly.
Yeah, for this particular question, you can take it directly. Y is equals to x, and
in other cases we cannot take like this.
Y is equals to x by 2. In this case, it's happening.
Yeah.
But other cases, I have to look into.
Okay.
Maybe there might be. See, in question number 7, there will be a rhombus kind of thing.
Okay.
So there you have to be careful.
Okay.
Okay.
Checking is required whether the values are. Yeah.
See, what you have to do is fix one x first.
Yeah.
Fixing one x first, look at how y is varying, how the limits of y is varying.
It will vary according to the given condition. Here
it will vary according to the given condition, or
if it is negative value, then it will change, of course, according to the equation. Right now?
Yeah. Just a second. Okay, once if you solve this thing, what will I get? I know that fxy of x comma y is 2 by 3.
And now I have solved it. It's coming the right answer.
Right answer. 2 by 3 dy.
It will be 1 by 6.
It will be, if you compute this, yeah, quick calculation will be 2x by 3 minus x by 3 dx.
So the way I understand it, you are just doing a surface integration, right?
Right. This is 1 by 6. You will get 1 by 6.
So, sir, in double integration, there is no fixed order that I have to integrate the y term first or the x term first.
No. You can take it anyway. See, taking vertical strip, I am integrating y first and x next. So you can also take this horizontal strip by considering one particular y, fix one y, and look at the limits of x.
The limits will change. The limits will change accordingly.
Yeah, limits will change accordingly.
Yeah.
Sir, I understand this concept well. Can you just tell me from the concept, like probability of y is less than x less than 2y, how to change the limits of x and y from there? Like here, if you can say, the highest I have to take, like 2y have to take as a x, then y can be x by 2, like that, right?
Y is x by 2.
Yeah, and then we'll take y, that is 0 to 1 running from.
Then you will take x.
Is it?
Yeah.
Oh, okay, got it.
So
Got it,
fix
got it.
x.
Yeah, got it, sir.
Yeah. So it's just like in discrete case, you will sum over y first, fixing x, and later you will sum over whole x. Right? Remember this thing? Summation
Yeah, got it.
belongs to tx. Yeah. Y belongs to ty. There it is summation because it is discrete. Here it will be integral because this is continuous. That's it.
Okay, sir, got it.
Okay. Yeah. So this will be 1 by 6. So let's come to this, also solve this ninth question. So ninth question is, we have been given some PDF, joint PDF.
Sir, I have problem in calculating the limit of y.
Okay. Let me read the question. So this is fxy. So joint PDF is given to us. I'm just muting everyone. So C x times x minus y when x is running from 0 to 1 and minus x. So this is, I guess this is straightforward, right? I guess, let's see. This is 0. This is a joint PMF given to us. Joint PDF, sorry. So what we have to do is, we have to integrate on the whole region. So you know how y equals to, so find this particular region first. So our interval goes from 0, x runs till 1, and later in this region, y is in between minus x and x. So this is y is equals to x, and this is y is equals to minus x. Our region will be this thing. Have you plotted this?
Yes, sir.
Oh, okay. Okay. Now see. Now in order to find the limits, or it's just like, see, joint PMF, if I integrate over whole minus infinity to infinite on both x and y, I should get 1. Right? Am I right?
Yes, sir.
Integrating throughout, right? And now I have in between 0 and 1, x is in between 0 and 1, y is in between. If I take one particular strip, so if I take this particular strip, this is x is equals to, this is x, let's say x. Now look at the limits of y. So what is this?
So minus x,
And what is here?
y equals to x.
X. So at x, at one particular value of x, I am fixing x. Looking at the limits of y, my limits are from minus x to x, right?
Yes, sir.
Okay. Now this particular thing will be shortened to, remaining will be 0, and this will be shortened to 0 to 1 x limits. So, and y limits will be, once I fix x, my y limits will go from minus x to plus x, right? So look at
Yes,
one
sir.
particular x, fix x and look at the limits of y in terms of x. So here y runs from minus x to x. I will just simply substitute the lower limit and the upper limit. So lower limit will be minus x and upper limit is x. So these are the limits of y. And also I know that fxy of x minus y is given as something like cx. x minus y dy dx. So this should be equal to 1. So when I integrate the whole PDF or the joint PDF over the whole interval, I should get 1. Right? This is the property of probability density function.
So I have used this limit and I have got answer c equals 3. But answer is c equals 2. It doesn't matches there.
This
So
thing.
I used this limit and I got the correct answer. That
Yes,
is
sir, I also got the correct answer.
Okay, let's see. 0, 1. I just bring c outside because it doesn't play any role. So now this minus x, this will be x square minus yx. So first one is dy and the outside one is dx. Now 0 to 1, this will be x square minus yx. We are integrating over y. So that will be x square y minus xy square by 2. Right? X square y.
So at this point I was mistaking because I was integrating using the limit of y, I was integrating the x word. X
Yeah,
term.
this thing.
Okay.
Be careful with this thing.
Okay, sir.
So whatever the limits of this is the limits of y. Y is equals to y is equals to, right? So you
Yeah.
have to integrate over y. And later these are the limits of x is equals to 0 and x is equals to 1. So you have to integrate it over x. Like,
Okay, sir, I've got the answer now.
okay. If you compute this, I guess you will get something like 2.
Yes,
Okay.
sir.
Okay. And 11th question, right?
Yes, sir, 11th question.
Okay, what is 11th question? So there is an joint density given to us and you wanted to find the probability that x is greater than or equal to y. Fxy of x comma y is given as 6x square y in the interval 0 to 1, 0 to 1.
Sir, can I say one point if I'm allowed? Sir, like in this question, we have to find the probability that x is greater than equals to y. So, sir, x can be integrated from 0 to 1, and then y can be integrated from 0 to x, if I'm not wrong, right?
Yeah, looks like. If you just draw the graph in this particular region, what, see, this is from 0 to 1 and 0 to 1. So this is x is equals to y and x is greater than or equals to y is this thing.
Yes.
So the same thing, same lower triangle.
Yes.
So it will run from 0 to x. Y limits will run from 0 to x and x limits will run from 0 to 1. Right, you are right.
Yes, sir. Thank you, sir.
So see, the same thing. What I will do is I will just fix x. So I will take one strip at x. So I will just observe the limits of y. So what is the lower limit of this y? This thing.
X.
This thing. Lower limit.
0.
0, right? So
Yeah,
this is
okay,
x
for y,
axis.
yes.
This is x axis.
Yes.
So this is y is equals to 0. And what is the upper limit?
X.
X. So for if I fix x, my y limits are 0 to x. So what I will do is I will first write the y limits, which goes from 0 to x. Later I will look at the y limits, sorry, x limits. So x runs from 0 to 1. So the whole, so 0 to 1 is the x limits and 0 to x is the y limits. So if I wanted to do it in reverse, so I just wanted to take this thing. If I wanted to integrate x first and y next, then what will be my limits? I will just fix one y,
so
one
I did
particular
this
y.
way. So it
It
was
will
from
be
y to
y to
1.
1. Yes, sir.
Yeah, this will be x is y here and x is 1 here, right?
Yes, sir.
So this particular thing can also be will also be equal to y limits also from 0 to 1
0 to 1. Yes.
and x limits will be y to 1, fxy, x minus y. Now see, this is dx and later dy. So this is just the interchange of limits.
So in these kind of question where a function is non-uniform, I think we should always prefer this strip thing.
Yeah,
We
strip
should
thing.
get in.
Right,
Because
right,
sir,
right.
here also I was what I was doing here, I was taking x limits from 0 to 1 and again the y limit also from 0 to 1, which was given in the joint distribution. I was taking the same thing because
Okay.
I was not taking this strip thing. I
Yeah,
think that part I was mistaking here.
right. So
Okay, sir.
yeah, fix x, find the limits of y in terms of x, then look at the limits of x final. So, so two steps, use that.
So in
And
every question we can do this thing. We can switch.
yeah,
We can take
every
either x limit or y.
yeah, every question.
So this thing, either we can take vertical strip or the horizontal one. Both the things are used in every question.
Yeah, both the things you can use. It will definitely be equal.
Okay, okay, sir.
So we are just computing the area. However, I am computing the area is same, unique. So area of that particular region should be unique.
Okay,
But I
sir.
think better to follow only one pattern, sir. Otherwise,
You might confuse sometimes.
Yeah, it is better to either follow the one pattern, do first X or do first Y. So that mistake, because this is a prone to mistake area. Most of the time here we get.
So it's not necessary, right, that we take the limit from y to 1. We can also do it like 1 to y. Same thing, right? Yeah.
1 to y will give you negative, right?
No. Even if it does, 0 to 1 will straighten it out.
Is it? I don't think. See, if you are interchanging the limits, it will give you negative sign. So 0 to 1 x dx
Y to 1
will be minus of 1 to 0 x dx. So this is limit property.
X
So I
is
wanted to
changing from
integrate
Y
it
to
from
1.
a to b f of x dx. This will be minus of b to a f of x dx. So if you are interchanging the limit values, then you will get a negative thing.
Okay,
Look
sir.
at why this will be true.
Sir, but in case of area computation, even though if it is a negative, we consider it as a positive.
Exactly.
Because area can never be negative.
Exactly.
Not like that. So
yeah, in surface integration, actually, what happens is dz dy dx, correct?
In
so
area computation, we
But
can
area
change
comes,
the
area
interchange the
comes
limit.
after calculating the limit. Before limit, it is not area. When we calculate after integration, then it becomes area. As I think so.
And also, it's not like dx, correct? It's like del x, moreover.
Yeah.
So
it is del
If it is
x.
a partial, then it will be del.
Yeah, it is partial, right?
Yes.
It is partial.
It's
So
not
we
dx,
should,
dy, dz.
we should not do negative.
We only use
positive.
partial.
After integration, we can fix the positive negative. But before that, it is, I think,
okay,
affecting
maybe
the
I'm not that sure about this reversing the things. As far as I know, if you
No,
invert
it is correct, sir.
So that is correct. If you interchange the limit, the value will be negative. That is correct. But what I'm telling is when we are computing area, in that time, if we interchange by mistake, if we interchange the value and the final value will be negative, then we consider it as a positive. Since we are computing area, and area can never be negative.
But here area comes into picture after integration, not before integration.
After integration.
So after integration, we are taking up area for the calculation of probability only.
I think here, actually, your law, whatever 0 to 1 x dot dx minus 1 to 0 x dot dx holds true here and everywhere. Actually, what we are doing right now is x dot del x. So that way it does hold true.
Okay, maybe. Maybe.
Anyway, same thing.
This is not like the correct
Okay,
way
you
of.
can. If you are that sure, you can.
Okay, let us proceed. No problem.
Yeah.
The same thing.
Okay, maybe I will look into this and I will just confirm.
Okay.
Session. Okay. As of now, just follow lower limit. Is lower limit. Keep it downside and upper limit you keep it above. Okay.
Yes, yes.
Okay. So the 11th question is done. Let's go to AQ 5.4. Before that, there is something in the lecture. So lecture 5.4 is about computing marginal densities. So let me take out that lecture first. Okay, around 16 minutes, someone asked this question. May I know?
Yes, sir.
Yeah, yeah.
Around 16 minutes.
Around 16 minutes, it's like some region 0 to half, cross 0 to
Uh,
half, union
Sir,
half,
actually, sir
1
is
cross.
doing slicing over the graph. How it is doing that,
He is
and
doing.
how is doing that slicing part, and how is he's calculating the f of y, the marginal of y.
Hmm.
I am also facing this marginal calculation, sir. How to step by what is the standard step to do this? Get the final answer.
Yeah. Okay.
Because initially we have to do by a long method. You cannot go shortcut first time.
Oh, there will be shortcuts. Okay. We know this is joint PDF. Right? If you know this joint PDF, computing marginals will be the same thing we did in discrete also. Uh, marginal of, if you wanted to find the marginal density of random variable x. So I want x. So what I will do is I will sum over y,
Yeah.
sum over whole y, which I don't want. So here summing over means in continuous case it is integrating over whole y. Integrating it over dy, right? Same thing. Discrete and
So
continuous
so
both are
the
same thing.
margin will be the single integration over the support of the complement event, right?
Yeah. I don't know what's complement event.
No, sir. The complement of support will be the y support, and you'll find the
Yeah,
marginal
this
of
is
x.
y support. Yeah, it's not minus infinity to plus infinity. Just look at till support. Integrate over y belonging to the support of y. Yeah. See this that thing. I want marginal density of x. What I will do is I will integrate over the support of y. So which I don't want. I don't want to look at the marginal of y. So what I will do is I will sum over or I will integrate over the support of y. So I will get the marginal of x. Same thing for marginal of y. What I will do is I will integrate over support of x, which I don't want. I don't want x here. So I will integrate it over. Okay, these are the marginal densities. When a joint density is given to us, joint PDF is given to us. From joint PDF, how we compute marginals is we will just integrate it over unwanted random variable. Okay. So if you don't know joint PDF, we cannot compute this. So this is just for if you know the joint density as fxy of x comma y. With that, what I will do is I will integrate it over unwanted random variable over that support. Now in that example, in that particular example, how we do this is if I have joint PDF around this region. So this is the region. So this is let's say 1 to 2, and this is from 0 to some 1. Okay, I know that if I compute the joint density, I say this is uniform. So then joint density will be 1 in the region 1 less than x less than 2 and 0 less than y less than 1, otherwise 0. Now what I wanted to find is, I wanted to find the marginal density of random variable x. How this is nothing but marginal density. This is nothing but, if you observe, this is in discrete case, this is nothing but probability that x is taking value x, right? If I wanted to look this in discrete thing, if I know that this will become joint PMF, so joint PMF will be fx of x, which is nothing but joint PMF will be probability that x is taking the value x. Even the same here, what I want is marginal density of x. That means this particular x, there is some x. I want the probability that x takes this value x. So if I see this particular line, a straight line, throughout this line, my x will be x. So if I take any point on this line, my x coordinate will be x only. Right? So this is, if I wanted to look at in the continuous thing, I will take this particular, I know that the probability that taking x, a particular single value will be 0. So what I will do is, I will look at a smaller region around x, around this x, very small region.
So which question are we discussing now?
It's in lecture marginal densities.
Okay, okay, sir.
Sir, this concept of taking a smaller region around X is due to the fact in a continual distribution we can't take a value at a particular point, right?
Right. So at a particular point, the probability will be 0. No point of talking about that. So around x, when I say around x, small interval of x, smaller interval, there will be a probability. So therefore, I can talk about the probability density function. So that is why we take around x. So in this interval, this small x, this will be very small, very negligible interval. So this strip I have to find.
This is what we call dx.
This is what we this is dx, right? A small interval dx. So what if I look at this particular strip, I should integrate it from. So I just wanted to sum over all the unwanted random variable. So what I want is, I wanted to sum it over in along this strip. So I have to integrate y along this strip. So y runs from y is equals to 0 here till y is equals to 1 here. So what I will do is, I will integrate it from 0 to 1 fxy x comma y dy. So this is this is the unwanted thing. So I will integrate it over along the whole support of y. So like this I will get like this I will get the marginal density of x. So if I want marginal density of y, the same thing. So I will take y.
Here we will not integrate double integration.
No, here we will not integrate double integration. Here we will just integrate those particular random variable which we doesn't want. Okay, we wanted to find the marginal density of x. What we will do is integrate over unwanted random variable y along the support of y. Okay, opposite thing. So if you want marginal density of x, integrate it over y. If you want marginal density of y, integrate it over x. Okay. So finally, if you compute this, this will be dy and it will be again 1. Similarly, if you wanted to compute fy of y, so marginal density of y, same thing. I will take a smaller strip, and this strip, along this strip, I will integrate x. So I will look at the limits of x first.
How
Limits of
this
x will be
this one came, sir, 1 into dy?
this fxy of x comma y will be this thing, right?
Okay, already the joint already is
Yeah,
given.
joined we know that will be 1.
Yeah, that's right. We integrated over this.
Yeah. Now, if I wanted to find the marginal of y, x will go from 1 to 2. So this is 1 to 2 fxy dy. So if I integrate it, this will be 1 dx. So I have to integrate it over x because I want marginal density of y. So this will also be equal to 1. So once I get marginals as 1 and joint is also 1, I can see that product of marginals is equal to joint. So I can conclude that these are independent random variables. Like this, in the lecture also it is given. In the lecture it is given that given region is like this. So this is x is equals to 0, half, and this is 1. This is half, and the region given is this. For this thing, if I wanted to find the marginals, for finding marginals, before we find the join, so fxy of x comma y, what will be fxy comma x comma y? So what is the join distribution?
Area of the
How
two
this will
squares.
be?
Area of the two squares.
Area?
Area of the two squares will be the
For the particular value of x one y and then on another particular value of x and y.
Yeah, when 0 is when x is in between 0 and half and y is in between 0 and half, we get this area is half into half, 1 by 4, right? We will get 4 here, and this will be 4 when 0 when half less than x less than 1 and half less than y less than 1 and 0 otherwise. Is this correct? Yeah, this is correct. And also you can say if this is the region D, as in lecture, I'm just taking the lecture itself. If this is region D, just compute the area of this. Area of this is half, 1 by 4. Area of this is 1 by 4. The total area will be half. So joint density will be 1 by D, which is 1 by half, which will be 2 in the given region and 0 otherwise. So this is correct. Also the previous one is also correct. Let us follow what professor said. So if this is the region D, I said including these two squares, smaller squares, the area will be half. Therefore, the joint PDF will be 1 by area, which will be 1 by half, that will be equal to 2. So once we get the joint PDF, we can compute the marginals of this. How we compute marginals of this is just by taking the strips. Now I want marginal of x. Let's say I wanted to find fx of x. So what I have to do is I have to integrate y over support of y fxy x comma y dy, right? But if I am considering strips, see, along this from 0 to half, it is distributed in between 0 to half. Y is distributed in between 0 to half. But when from half to 1, it is distributed from half to 1. Now what I will do is I will split the things. I will split when 0 less than x less than half, one case, and half less than x less than 1 as another case. Okay. So in this particular region, if I take a strip along some x, if I take a strip along some x, my y values will go from 0 to half. So therefore I have to integrate it from 0 to half to dy. Now in this particular interval half to 1, if I take some other x region, some other x, so maybe this is x1, x2. So my y limits will run from half to 1, 1. Right? Find the limits, lower limit and upper limit of y. So this will run from half to 1. Support of y. Basically, I am computing the support of y. Support of y is from half to 1 in this particular interval when x is in between half to 1. So this is 2 dy. If I integrate it and compute it, I will get this will be 2y and this will be 1 and this will also be 2 minus 1 1. Is this correct? Silent. Am I audible?
Yes, sir.
Okay. So I'm just computing marginal density of x, of random variable x. So how I will compute is I will integrate it over y, which is unbounded. So actually our regions are different in both the cases, both the intervals. So I have splitted it into two intervals. So when x is in between 0 to half and when x is between half to 1. So when x is between half to 1, I have a strip. In that particular strip, support of y is running from 0 to half. So I will integrate it over 0 to half. Fxy of x comma y is 2. So 2 dy. In the same way, in the second region, half to 1, if I consider a strip, the support of y runs from half to 1. So I will integrate it from half to 1 to dy. But after computing it, I will get both the cases, I will get 1. So I can find simply write it as like this. This particular thing, marginal density of x will be 1 when x is in between 0 and 1, 0 otherwise. Anything you got or
yes, sir. If it is different, then we will rewrite as it is, right?
Yeah,
sir?
if it is like something like this, right? If it is half, we will write it as it is, like this itself. We don't combine.
Okay, okay.
As it is same, we can write it like this: 1 when the x is in between 0 and 1. So now if I wanted to, this is the marginal, I got this. Now this is a PDF of random variable x. So forget about marginal and everything. So this is one PDF probability density function of one random variable x. So if I wanted to draw it and show it on the graphically, this is how it will look. When x is in between 0 and 1, it will take 1 and rest of the cases it is 0. So this is what Sir has drawn, professor has drawn on the at that
Yes, sir.
particular
This
time.
part, yeah, this part, I could not understand
Yeah.
how
Now
this is slicing part is done. Yeah, I
see,
mean, sir.
this is a random variable now. X is a random variable with probability density function taking value 1 in between the interval 0 to 1, 0 otherwise.
Yeah, yeah, I got that point, sir. But
Mm.
if you do it on the 3D plane or in GeoGebra or something like that, then it would be good. Actually, visualization of that part is not. Actually, I'm not understanding that the visualization part of the slicing.
Okay. Maybe in the next session on Tuesday session we can see it in GeoGebra.
Yes, sir.
Sir,
Visualization.
sir, one more question here. Had
Mm.
these two probability been different, then what should we do in that case?
We don't combine that. We will leave as it is.
Sir,
This.
suppose like we have on x-axis from 0 to 1 and
Mm.
y, there was a question related to this, 0 to 1 and y was from 1 to 2
Mm.
and x from 1 to 2 and y was from 1 to 0,
Okay,
sorry,
okay, okay.
0 to 2.
Question number 2 you are talking about. No?
Sir, there
Question
was
number
a
2, 5.4. Yeah.
Yeah, there was a question. I will take that question now. It might give you some understanding. So first, whatever the question is, first identify the region in which identify the region D first. Okay. So here D is something unusual, which is given like this. So set of all xy's. Okay. I'll just write the region. So it will be from 0 1 cross 1 2. So this is like x is taking 0 to 1 and y is taking 1 to 2 in that region. So the region, I will draw the region union 1 to 2. When x is 1 to 2, y is taking 0 to 1. Union when x is taking 2 to 3, in the interval 2 to 3, y is taking from 0 to 2.
These are the areas. D is the area.
Yeah, these are the areas given.
The standard notation is this. 0,
Mm.
1, 1.
Okay. Let us try to get the regions first. So this is 1. Let us say this is 2. This is 3.
Krishna, yes. Yes. Mm.
Okay. So this is 1 and this is 2. So in this particular, when x is in between 0 and 1, y is in between 1 and 2. So this will be the region. Right? So this is the region. This particular 0 comma 1 cross 1 comma 2 represents this region. Similarly, we will try to find the other regions also. So when x is in between 1 to 2, y will be in between 0 and 1. Okay. This is the other region. And the third region is when x is in between 2 to 3, y is in between 0 to 2. That means this will be this. right? Once you identify the region, what we want is marginal densities of x and y. Now what I will do is I will try to find
Sir,
y.
I understood about X. I had problem with Y, marginal with Y.
Okay, let us try to find y, and later we will see x. Okay, so I want to find marginal of y. So what I will do is, here also I will consider two cases. So when y is 0 to 1 and when y is 1 to 2. Okay, let us try to take two cases. When y is 0 to 1 and when y is 1 to 2. Okay, now when y is 0 to 1, in this particular interval, I will look at the smaller strip around some y. This particular strip around y, and I will see the limits of x. So limits of x is 1 to 3. So what I will do is I will just integrate it from 1 to 3 fxy of x comma y dx. Hello.
Yes, sir, I understood.
Okay. So what is fx? So this is the region D. So what is fxy of x comma y? So what is the joint?
So 1 by 4. 1 by 4.
From 1 to 2 also, no? In case of
this
marginal of y.
1 area is 4, right? Area is 4, so fxy of x comma y will be 1 by 4 in this particular region, red region maybe. So in that particular region, and 0 otherwise.
Sir, I don't understand how it's 1 by 4.
Okay, let us say this is region D. So compute the area of this region D. So this area will be 1 into 1 1. This area will be 1. This area will be 2. So the total area will be 1 plus 1 plus 2. It will be 4. So as the area is 4, the joint density will be 1 by area. So it will be 1 by 4.
Okay. If it is not given, sir, then we can calculate the whole region area and we can take inverse of that. This will be the joint PD, right? Okay.
So it just said uniform, right? It's in the uniform.
Yeah, if it is given, they're uniform.
Yeah, it is given that
Yeah,
it's uniformly distributed. So just inverse the area. So that will give you the joint. So this will be 0 otherwise. Now we know that.
One doubt here, sir. It is only uniform, then only we need to consider inverse of here, right?
Yeah. If it is only uniform, if at all it is uniform, then only you can conclude that my joint PDF is inverse of it.
If it is other distributions, then we have to do according to that formula, right?
Yeah, according to that particular formula.
Okay. But I think we have not encountered any question.
No. As of now, we haven't encountered.
And here in the case of marginal FYY, sir, what about the y value from 1 to 2?
1 to 2 we will look at that one.
Okay.
So now when y is in between 1 to 2, I will take a strip. This is y and this is another strip, the same y. Right, in this particular y, I have to consider
addition of both.
Yeah. So this limit will go from 0 to 1, and again it will start from 2 to 3. So 0 to 1 fxy of x comma y dx plus 2 to 3 fxy of x comma y dx.
Good one. This is
Okay, sir. Actually, I understood it right now. What mistake I was doing was that I was moving, since I was finding the marginal for y, so I had to move along x. So I
Yeah.
was dividing x into intervals and looking at that. That was the
No,
mistake I
no.
was doing. Okay,
So
sir.
for
Thank you so
x, you
much.
have to divide. Yeah. For x, it will be vertical strips. Consider take three different intervals 0 to 1, 1 to 2, and 2 to
And
3.
here we will take joint PDF fxy of xy dx 1 by 4.
1 by 4. This all will
Fine.
be 1 by 4.
Yeah, now it is very clear, sir, because marginal was
Yes,
very
sir. Yes,
difficult
sir.
to understand in the lecture. It is fantastic.
In fact, after this, I think I got my concepts clear.
The first time I also got to understood the marginal. Yeah, thank you, sir. Thank you. So nice.
Okay. So if you compute this, luckily you will get the same values. Both will be same, and you can combine this into single
Yeah,
value.
maybe it is same, sir, but concept should be clear where
Yeah,
why
yeah.
it is coming same.
Yeah, yeah.
Because every time you do not understand, then become confused.
Okay.
So we
Thank you.
can also use area method here.
Why area? How?
So because it's uniform, so can we use here the area method?
So you are saying that half of the area will be from 0 to 1 and half of other area will be from 1 to 2. Is it like that?
Oh. So can you just tell me how to compute the marginal of x here? Then
Okay.
I'll be clear about this.
Okay. So for marginal of x, so this is okay. This is 1 by 4. So this will be x by 4, and this will be 3 by 4 minus 1 by 4. You will get half for this, and here also you will get 1 by 4 plus 1 by 4, the same half thing. You will get the half only. So this I can write it as half when 0 less than y less than 2, 0 otherwise. So if you wanted to compute x for this, marginal of x, okay. So I'll just take this diagram below. Okay. So now I wanted to compute. I wanted to compute this fx, marginal of x. So what I will do is I will consider three particular intervals when x is between 0 to 1, when x is between 1 to 2, when x is between 2 to 3. Okay. When x is between 0 to 1, what I have to do is I have to take a strip along some x. So this is x. So I have to look at the limits of y. So y is running from 1 to 2. So what I will do is I will integrate it from 1 to 2 fxy x comma y dy. Now I have to integrate it over y because I don't want y. Or as we are computing marginals of x. Now this is for x is in between 0 to 1. When x is between 1 to 2, similarly take another strip in between this interval. Look at the limits of this particular strip. So this will go from y0 to y1. So 0 to 1 fxy x comma y dy. The same thing for when x is in between 0 to 3. So take a strip, look at the limits of y is 0 to y is 2. So what I will do is 0 to 2 fxy x comma y dy. Now just compute these values. So this will be integral 1 to 2 1 by 4 dy. This will be y by 4 2 to 1. So 2 by 4 minus 1 by 4, you will get 1 by 4. Similarly compute this 0 to 1 1 by 4 dy. So same thing, 1 y by 4 when 1 is 0, 1 to 0. So this will be 1 by 4 minus 0, you will get 1 by 4. Similarly compute this 0 to 2 1 by 4 dy. This will be y by 4 2 to 0. So this will be 2 by 4 minus 0, which will be half. So what we got is the value of this is 1 by 4. This is 1 by 4. This is half. So if I wanted to write in a simpler way, how I can write is, I can combine these two. As these are equal, I can simply write it like this.
From 0 to 2. X goes
Yeah,
from 0 to 2. It's 1
when
by
x is in between 0 to 2, it takes value 1 by 4. When x is in between 2 to 3, it takes value half. Okay, this is all. So initially you divide it into intervals. If you are not that confident, initially you divide it into subintervals, where you will have smaller regions. Once you divide it into smaller regions, just take the strips. Use the strips concept and you can compute it.
in uniform or in non-uniform, in both the cases, we can use this strip method.
Yeah, this strip method, but make sure that you are using fxy of x comma y correctly.
So regarding fxy of x comma y, that cannot be broken down into any other piece, right?
No, that cannot be broken. So that is what
if we, I thought like we can break it. If we break it into some other piece, the limit might change. So that cannot be done, right?
No.
In non-uniform cases, sir, it will be different. fxy of xy will be in the form of an equation, right?
A function of x and y.
Yeah, a function of x and y, and we have to integrate here with respect to dy and keeping x constant.
Yeah, keeping x constant. Those are the cases. So that is the change there.
Yeah.
But intervals and everything, limits and everything,
it will accordingly same, according to same.
The same thing.
Yeah.
Use the strips and find the limits of the interval, integral, and rest of the things are same.
Yeah. Nice.
Okay, this is about 5.4. Okay, let me take a few some more questions of some.
So one doubt in 5.4.
Sir,
in question number 4, we have to find the marginal density of x. So for this, I am unable to find the limit of x. Sorry, limit of y.
Okay, let us do it then. Question number 4, right?
Yes, sir. So you can only tell me the limits and how we get it. This is just the question.
Okay. Maybe you can tell me the limit now. Just see, it is given that fxy. Okay, I don't want to write this thing also. Let's go directly draw the. Okay. Now see, my x is in between 0 to y by 2, right?
Yes, sir.
And my y is in between 0 to 4. See, my y, let's start from y now, because we know the y limits perfectly. So when y is 0 is this, y is 4 is this. Now we have our x is in between 0 and y by 2. Now also let us draw this. Whenever like this things came less than something, just equate it and draw the lines of those. So draw the line of x is equals to 0 and draw the line of x is equals to y by 2. So x is equals to y by 2 is nothing but y is equals to 2x.
2x, yeah.
Okay. So draw the line of y is equals to 2x. Something like this. Right?
Yes, sir.
What is x is equals to 0?
X equals to 0. So it's the y-axis.
Y-axis, correct. So this will be y-axis. Okay. And my x is in between these two. So 0 and y by 2. So what is the region? So my x is in between these two lines.
Yes, sir.
So this will be the region. So it cannot go above 4. So it is bounded above 4. So this triangle will be our region. Right?
Yes, sir.
Now what I wanted to find? I wanted to find fx of x. Right?
Yes.
So what I have to do? I have to integrate over y. Right? Take a strip now. Okay. this is at x. Let's say around x. Now what are the limits of y?
So
Y to
equals
y to
2x
4.
to
This is y is equals to 2x.
2x to 4.
X to 4.
Right. This is 2x and this is 4. So therefore this will be 2x and this will be 4. In the interval, what is this value? This is 4. What is this? Or what is the limit of x? So how many values x can take? What is the maximum value x can take?
2.
2.
2, because you get it from here. So y can take till 4, so x can take till 2.
Yes, sir.
Right? Right. Now you see, when x is in between 0 to 2, so my limit will be 2x to 4 fxy of x comma y dy. It is 0 otherwise, because we don't have region in other values of x.
Okay, sir.
Okay.
Yes, sir.
So what is fxy? No.
So it's 1 by 4.
Right. So now you have the limits with you. You know what is fxy. You can compute fx of x, right?
Okay, sir.
Yeah. Okay. Okay. Let us move forward and let us look at independence, conditional. Any doubts in that?
No, sir.
Question number 5 on this.
On
5.4.
5.4. Okay. Okay. So question number 5 says there is a random variables x and y uniform in some region D. So we have to identify that region first. Right, this is question number 5. So identify that region. Which region? The region is bounded in between 1 to 2. X is bounded in between 1 to 2. And also another line, x minus y greater than or equals to 1 and y is greater than 0. Right. Let us see this. Okay, as we have said, in these cases, just make it equal to 1 and draw that line, and after that look at the region. Substitute origin in that and look whether it is satisfying or not and find the region. Okay. So first thing, we know that x will be in between 1 to 2. So plot that. So our region will be in between this, inside this interval. And next thing is, draw this line, x minus y is equals to 1. So x minus y is equals to 1 is nothing but y is equals to x minus 1. Right? How that line will look when x is 0, this is
minus 1 to 1.
Yeah, minus 1 to 1. So something like this.
Yeah.
Right? Now if I substitute origin in this, will it satisfy? So 0 comma 0, 0 minus 0, 0 greater than or equals to 1.
No.
Being satisfied? No, right? So that means origin will not lie in my region.
Yeah.
So opposite tree. So this is the region. So I don't want to shade whole the region because my region will lie in between 1 and 2. Okay. So finally we got our region now. And also y is greater than 0. So no need to shade below x-axis. So this is our region. So this is y equal to 0. This is x minus y equals to 1. In between these two is our region. Okay.
Yes, sir.
Yeah. The one who asked this question.
Yeah. Yes.
Yes. Okay.
Till this even I got.
Okay. Region you got, right?
Yes.
Okay. Once you got the region, compute the area of this. So we said this is uniformly distributed in this region.
Yeah.
So what is the area of this?
It's half.
This is 2 comma 1. This is 1. Yeah, 1 half. So the area will be half. Now what is the joint PDF?
2.
Yeah. So joint PDF will be 2 in this particular x comma y belonging to this region, 0 otherwise. Now I have to find, I know this, now I got joint PDF. I know the region also. I know that it is also uniform. I just have to find the marginals now. So let us find this thing. So fx of x, marginal of x I wanted to find. So in order to find the marginal of x, I need to take the strip, vertical strip around x. So let us say this is x. After taking the strip, find the interval limits of y. So what is the lower limit of y?
0.
0. Correct. So this is the lower. What is the upper limit of y in terms of x?
X
X minus 1, sir.
X minus 1.
X minus.
X minus 1.
It is x minus y is equals to 1. Line is x minus y is equals to 1. So y will be x minus 1.
Yeah.
So I know the limits now. So I just have to integrate it from 0 to x minus 1.
Okay.
Fxy of xy is 2 dy.
Actually, I have considered the limits from x minus 1 to 1. Is it equivalent? No, right?
X minus 1 to?
X minus 1 to 1.
No, that is not correct.
Yeah.
So if you are looking, see, you have to look at vertical strip. If you are wanted to find the marginals of x, you just have to fix x and take some strip around that x and look at the limits of y.
Yeah, sure. I got it.
Yeah.
I got it. I think now it's clear.
Yeah. Now you can compute, similarly you can compute y also. Yeah. Okay. So independence, conditional, rest of the things are fine, I guess. So just submit your graded assignment as early as possible. Any doubts in tutorials of week 5? See, because in next session Tuesday, I just wanted to use this GeoGebra applets and show you some distributions, some graphs of some distributions, and I will give you an insight of how that actually looks, so everything visually I will try to give. Okay, apart from that, any other doubts you can ask it here, or else we will meet on Tuesday.
Sir, any suggestion you would give accordingly, like how we can develop this insight?
Insight what?
Attacking
I
the
mean,
questions.
how to get the
Okay.
also understanding it. Like, sir, I read the book Shiva and Athriya. That was very similar to the slides that we have. So that wasn't of much help.
Okay. See, once you understand how the things are looking visually, then it will be easier. So my suggestion is proceed in a stepwise manner. If you know how to graph the PDF or PDF or CDF, just graph it first. Once you graph that, everything will get sorted automatically. Okay.
Okay, sir. Thank you.
Okay. So most of the questions which you are seeing in week 5 can be done graphical. Most of the questions. Okay.
So, but we need something to like clarify the doubts. Like the doubt that I had, the one that we discussed for the marginal of y, I just got that little bit of intuitive, and then I could do it. Like, I don't think I'll have any problem solving these kind of questions. But again, if I get stuck into something, then that is what I was asking for.
Oh, maybe I can suggest you practice more and more problems as of now.
Sir, I have been doing that question from the past 2 days.
Oh.
I
There
was
is
not
no,
able
there
to.
is no
Even I was dreaming about
real
it.
time support stage asking.
So,
Something that we can like build that intuitive.
see, intuition. See, uh, if you are doing for the first time, getting intuitions will be really difficult. These intuitions will be built slowly, right? Once you understand the concept and once you understand how it is happening, then it will be easier. You will understand this when you solve more and more problems. As of now, I can only suggest that thing. Maybe I will see if I can come up with some more suggestions in the next session.
Okay, sir. Thank you so much.
Okay. Okay then.
Okay, sir. Thank you. So nice.
Yeah.
It was a good session, sir. Marginal, very confusing, but
Thank you.
most of the thing got cleared now. We can attack now questions.
Yeah. Please do attack the question.
Okay, sir. Thank you.
Thank you, sir.
Okay. Thanks a lot, and meet you on Tuesday.
Thank you, sir.
Thank you.
Yes, sir.
Host, you can end the session.
Thank you, sir.
Thanks.
Hello, sir. Are you
Hello.
there?
Yeah, Pranay.
Sir, I have a suggestion. Sir, can you please conduct few live session for the extra activities? It will be really helpful.
Extra activities.
Yeah.
Okay.
Yes.
Yeah, I will ask the team. Okay.
Okay, sir. Thank you.
Okay. Thanks. I will post this to team. Okay, they will take care.
Okay, sir. Thank you.
Okay. Chalo then. Bye all.